Alright, so I'm going to do some examples of integration by parts real quick. Hopefully y'all can see everything pretty well. I'm going to try to stay towards the middle of the board so that y'all don't get glare and everything. Cool. So let's think of an example. Cool. So we got x to the fourth natural log of 2x dx. Right. And so one of the tips is that if you have natural log in your function and you're doing integration by parts, you always make it your u. Because if you made it your dv, to get v you'd have to integrate it, and integrating natural log of 2x requires integration by parts, so you wouldn't want to do that. Cool, so dv is everything else, so that's your x to the fourth dx. Then du is the derivative of this, which is 2 over 2x with a dx, which is the same thing as just 1 over x dx. And then v, remember we want to integrate here. It's the integral of dv. Cool. That's going to be the integral of x to the fourth dx, which is x to the fifth over 5, and we'll leave it at that. We don't have to put the plus c here because it's just any antiderivative, not specifically with the constant. Cool. And so, where do I want to work at? I should start over a little bit, that's fine. Cool. I'll go over here. So, alright. We remember our formula, uv minus the integral of v du. And so we take u, which is natural log of 2x, v, which is x to the fifth over 5, minus the integral of v, which is still x to the fifth over 5, and then du, which is 1 over x dx. And I had someone asking, where does the dv go? Well, we don't really need the dv. It came from the original integral, and we just needed it to find v. So we don't have to include it anymore. Cool. And so the part in the front stays the same. It's just multiplication. And then we're going to integrate this. What we notice is that we have this 1 over x and the x on top. This can cancel and then turn this into a 4. So it'd be the integral of x to the fourth over 5 dx. And then another thing that I can do, rewrite this stuff real quick. This is x to the fourth over 5. It's the same thing as 1/5 x to the fourth. So I'm going to pull out that 1/5 right there. Cool. And so now I've got natural log of 2x, x to the fifth over 5, minus 1/5 times, and the antiderivative of this, which is x to the fifth over 5. We leave it as that, or we can simplify it just a little bit more to get natural log of 2x, x to the fifth over 5, minus x to the fifth over 25. Either of those are acceptable answers. Whichever one you'd want to put, I can live with that. Alright, so the next example we're going to look at is the integral of 3x e to the 2x. And so, what I'm going to do here is I'm going to let this 3x be our u, because then we get a simple du, versus if e to the 2x was u, then du would be 2e to the 2x dx, which would be a little clunky when we go to put it into our integral. So, what do we have? We have that u is 3x, so du is 3dx, and then dv is the rest of our integral, e to the 2x dx. So v, which is the integral of dv, is, all right, remember that the integral of e to the f of x is 1 over f prime of x e to the x. So if this is f, the derivative of that is 2. So 1 over 2 e to the 2x. And leave it at that. Right. Then we use our formula again. U minus the integral of v du. U is 3x. V is 1/2 e to the 2x minus the integral of 1/2 e to the 2x, and then du, which is 3 dx. Cool. I'm going to combine this stuff over here real quick. That's just 3x and 1/2 e to the 2x. That comes out to 3 halves x e to the 2x. All I did was multiplication, nothing too crazy. Minus, and then I'm going to pull the coefficients out of here. So I'm going to pull the 3 out. I'm going to pull the 1/2 out. That gives us 3 halves, because 3 times 1/2 is 3 halves. And then integral of e to the 2x dx. Cool. We'll just bring it down. 3 halves x e to the 2x minus 3 halves times, and then we've already seen the integral of e to the 2x. That's right here. We get 1/2 e to the 2x. So 1/2 e to the 2x. Have our cheese. And cool. Just rewriting it, and I'm going to do this multiplication. 3 halves times 1/2 is 3/4 e to the 2x plus c. And then that would be your final answer. All right. And now we're going to do the example from the worksheet that was a little cuckoo. That was, we have the rate of electricity use be given by 10t e to the negative t. And we want to find the electricity use over the first t hours. Then we're going to integrate from 0 to t our function. And so what does that give us? That's the integral from 0 to capital T of 10t e to the negative t dt. And this is going to be an integration by parts. Right? We're going to have a u, we're going to have a dv. That'll be all fine and dandy. So let u be our 10t, and then dv is e to the negative t dt. Then du is 10 dt, and v, which is the integral of e to the negative t dt, is negative e to the negative t. Then we can write it out. uv minus the integral of v du. And notice here I'm going to drop the bounds for now, and then I'm going to evaluate with the bounds at the very end after we've gone through and done all of our stuff. So here we've got 10t, v is negative e to the negative t, and then minus the integral of negative e to the negative t times 10 dt, because our du is 10 dt. Cool. What I'm going to do is I'm going to combine stuff, cancel out some negative signs, get stuff kind of clean. So over here I'm going to have negative 10t e to the negative t. All I did was I moved this negative sign in the front right here. We've got 2 minus signs that will cancel, and then I'm going to pull this 10 out. So plus 10 integral of e to the negative t dt. One thing that's nice about integration by parts is that you're almost always going to get back to integral of dv. Right, dv is e to the negative t. You can probably pull coefficients out to get back to this, which we've already seen the integral of. Cool. So I'm going to draw a line right here, separate these. That's negative 10t e to the negative t, just copying that down, plus 10 times, and we already saw that the integral of e to the negative t was negative e to the negative t. Cool. And then combine, distribute negative signs, negative 10 e to the negative t minus 10 e to the negative t. And then one thing that I'm going to do before we evaluate it at its bounds is I'm going to factor out a negative 10 e to the t. So what do we get when we do that? We have negative 10 e to the negative t. That leaves us with just a t here, and then that is just 1 of the negative 10 e to the t. Cool. So now that we have this, it's a lot easier to evaluate it from 0 to t than it would be if we were like here, because we have a bunch more t's in different parts. And that's why I specifically wrote it out this way. Cool. So what am I going to do? I'm going to have negative 10 e to the, we're plugging in capital T first, so negative capital T times capital T plus 1 quantity minus, and then the evaluation of 0, which would be negative 10 e to the 0 times 0 plus 1. Cool. And so what do we get? So this part I'm going to write as negative 10. We have e to the negative t, which is the same thing as 1 over e to the t. I'm going to put this over e to the t, just because it makes it look a little simpler. And then t plus 1 still. And then this part over here, right, first we have two negative signs. That becomes a plus. E to the 0 becomes 1. And then we're left with just 10 times 1 times 1. So plus 10. And this is our final thing. This is our final deal right here. And we can call this like n of capital T or something like that. So that's this first part. You can pause it, take a screenshot, whatever you need to. Cool. And so now we want to move on to part B, and that asks what he used in the first 4 hours. So I'm going to write our n of t that we found. Recall that it was negative 10 over e to the t times t plus 1 plus 10. Erase the rest of the board. Cool. And so n of 4 would just be negative 10 over e to the 4 times 4 plus 1 quantity plus 10. I'll let you plug that into your calculators. You should get about 9.08 or something like that. And so I'm going to leave it here with integration by parts. If there are any other specific examples you'd like to see, either email me, put them in the comments, whatever you'd like to do. And yeah.